Welcome to 1.4, Solving Linear Systems, Part 1. Before we jump into three variable systems, we need to refresh our understanding of solving two variable systems. The first way we're going to solve x plus 3y equals 1 and negative x plus 2y equals 4 is to use substitution. So if we were to graph these two, we're looking for where they cross. We're looking for that point where they cross. So let's look at substitution. So what you want to do is solve for one variable in one of the equations and plug it into the other. I'm going to choose the first equation, this one right there. So I'm going to solve that for y or x. So x plus 3y is equal to 1. It doesn't matter what variable you solve for, but since x already has a coefficient 1, it just makes it easier. So I'm going to subtract 3y from both sides to get x equals 1 minus 3y. I'm going to take this x, what this x equals, and plug it in for x in the second equation. So that gives me negative parentheses 1 minus 3y, because that's what x equals, plus 2y is equal to 4. Distribute the negative. So negative 1 plus 3y plus 2y is equal to 4. And you now notice we only have one variable. So we combine like terms. So negative 1, 3y plus 2y is 5y. Add 1 to both sides. And then we're going to divide by 5. So y is equal to 1. Now once we have one value, we can plug this back in and find the second value of our point. We found the y value, and we can plug it in either one of the original ones, the x plus 3y equals 1. We can plug it into the negative x plus 2y equals 4, or we can plug it in right here, x equals 1 minus 3y. And since this is already solved for x, this makes our life a lot easier. So I'm going to plug it in to this one. So I'm going to take the 1 and plug it into x equals 1 minus 3y. So x equals 1 minus 3, and since y is 1, I'll plug that in. So that is 3. So 1 minus 3 is negative 2. So if I graph these two lines, they would cross at the point negative 2, 1. And that is your solution for that system. And that is substitution. Hopefully you remember this from Algebra 1, but it's been a while, so that's why we're going over it. So let's look at this with elimination. We're going to solve these same two equations, the same system using elimination instead. So I'm going to go grab that equation from up here, move it down here. There we go. So now we're going to use elimination. What we do is we try to get one of the variables to be exactly the opposite. So you notice we actually already have that. So we have x plus 3y is equal to 1, and negative x plus 2y is equal to 4. Now let's just double check. These both have to be in standard form. In other words, x and y have to be on the same side. Notice how the x's line up, the y values line up, the equal signs line up, and the number to the right lines up. This is a requirement for elimination, so they have to be in the same format. And you notice how the x and negative x, they are completely opposites. I need either my x's to be opposite or my y's to be opposite. My x's are already opposite, so if I add them together, that gives me 0, and that's the point. I need to eliminate a variable by adding or subtracting. So if I add these two equations, x plus negative x is 0, 3y plus 2y is 5y, and 4 plus 1 is 5. So that leaves me with 5y is equal to 5. Divide both sides by 5. Y is equal to 1. Take my y value, plug it into any of the equations. The original ones is what I have. So I'm going to plug it into the first one. I'm going to plug this into this first equation. So I have x plus 3 times 1 equals 1. So 3 plus, not 3, x, and 3 times 1 is 3. Subtract 3 from both sides, you get negative 2. So I get the point, negative 2, 1, which is the same answer as I did with the substitution. Same exact answer. So it doesn't really matter which method you use, just use the one that's easiest to do at the time. So that is a recap on how to do substitution and elimination. So let's get into do 3 variable systems. So lesson 1-4, we are going to learn how to visualize solutions of systems of linear equations in 3 variables, solve systems of linear equations in 3 variables algebraically, and solve real-life problems. We're not doing all that today, but we'll do some of it. Visualizing solutions of systems. So we have 3 variables, x, y, and z. We're used to x and y, but now we're adding in a third dimension, z. And they have the form of ax plus by plus cz equals some number d. And a, b, and c are all non-zero numbers. So you notice you have x, a y, a z term, and an answer. When you have 3 variables, you need 3 equations. So we have 3 equations. Notice they're all in that same form. X term, y term, z term equals an answer. X, y, z equals an answer. X, y, z equals an answer. So that is a requirement. Make sure they're all in standard form. The solution is going to be an ordered triple. It's going to be x, comma, y, comma, z. These go in alphabetical order if you forget. And we're trying to find those coordinates to make that equation true. Make them all true at the same time. So think back into geometry. The first picture right here, this is 3 planes. Now you notice 3 dimensions is a plane, okay? If we're looking for when they all equal the same, have the same x, y, and z value, that means they all share a point in the 3-dimensional plane. So you have 1 plane, 2 planes, 3 planes, and they all cross exactly at one spot. This solution has one answer. Okay, that happens for the most part. That's the type of question we'll be giving you. Okay, but sometimes that's not the truth. Sometimes all the planes cross on a line. So this one has infinite number of solutions. Not all solutions, but infinite number. So any point on this line is a solution to all 3 systems. Then we have the no solution. No solution is when they all don't cross at the same time. They don't share any points in common. So this one shares these 2, the green plane and the, I guess that's pink. The pink plane shares a line of values. The pink and the blue line shares a line, and the green and the blue line share a line. But they all don't share the same point, so there's no solution here. Again, here you got 2 parallel planes, so these never share a point, no solution. And here's another option that's possibility that all 3 planes are parallel. So we're going to look at solving systems, 3 variable systems algebraically. So we have simple 3 steps you can follow. First thing you do is you need to rewrite the linear systems in variables by using, rewrite the systems as a linear system in 2 variables by using substitution or elimination. Step 2, solve the new linear system for both of its variables. And step 3, plug them back in to one of the equations in step 2 to find the remaining variable. When you obtain a false equation, such as 0 equals 1, in any of the steps, the system has no solution, just like we do when we solve any algebraic equation. If you get a false statement, there's no solution, so you can quit. When you don't obtain a false answer, you get like 0 equals 0, This system has infinite many solutions. That's where they all cross in the same line, okay? And all you have to state is infinitely many solutions. So let's look at example 1. Now, I make sure I label. You can use letters or numbers. I typically use, let me see, what do I use? I usually use A, B, and C, and I put a circle around it so I know it's not part of the equation, because variables doesn't have to be X, Y, and Z, but in this case it is. So this one's A, this is equation B, this is equation C, okay? So I need to eliminate a variable. Now I need to pick one. So do I need to eliminate X's, Y's, or Z's? And I'll look for the one that's the easiest, okay? So let's take a look. It looks like I want to eliminate X. So between these two, I notice I can simply multiply this one by -2 to get these to be opposites, okay? So that's what I'm going to do. So I'm going to take the A equation, just what it is, and the B equation, to make those X, the coefficients of the X terms opposite, I'm going to multiply B by -2. Okay, so that's my plan. My plan's in purple. Okay, so I'm going to take the A equation, and I'm going to multiply the B equation by -2. So I'm going to take -2, -2 times 2x is -4x. Then I'm going to take -2 times -3y, which is positive 6y. Then I'm going to take -2 and times it by 5z to give me -10z. Equals. Now I'm going to take that -2 and times it by -7. That gives me positive 14. And notice now how my x values are completely opposite. So that means I can add them together. So 4x plus -4x is 0. That was my goal. Got it. 2y plus 6y is 8y. 3z minus plus a -10z is a -7z. And 12 plus 14 is 26. All right, so I need to do this again. We do this twice. So I used equations A and B. Now I need to choose two new equations, different equations, to eliminate x again, okay? This time I'm going to choose A and C because, not A and C, B and C. If you notice, if I choose B and C, if I multiply equation B by -3, these would then be the opposite. So that's my goal. Multiply B by -3. So that's my plan. So let's do that. So -3 times 2x is -6x. -3 times -3y is positive 9y. -3 times 5z is -15z. Equals -3 times -7 is a positive 21. All right, so we're just going to take C the way it is. We're not going to change anything about it. So C is 6x minus y plus 4z is equal to -3. And I'm going to add them together. So negative 6x plus 6x is 0. 9y plus a negative y is 8y. 15z, negative 15z plus 4z is negative 11z. And 21 plus a negative 3 is 18. All right, now I have two new equations, and just to keep it organized, let's name those two. So I have equations A, B, and C. We're going to equation D, and we're going to name this one equation E. Okay, so I do that just so we can talk about them and you know exactly which equation I'm referring to. All right, so you notice that the y values of these equation D and E are all both 8y. So if I multiply one of them by negative 1, I can eliminate the y again. And that's my goal. I take these two new ones and eliminate a variable. So here I go. I'm going to take equation D. I'm going to multiply that by negative 1, and then I'm just going to take equation E. Okay, doesn't matter. I could have multiplied E by negative 1, but I just did D. All right, so here we go. So we're going to take negative 1 and multiply it by this entire equation. So that gives me negative 8y plus 7z equals negative 26. And then I'm just going to write down equation E. So equation E is 8y minus 11z equals 18. Since now they're the opposite, I can add them. So negative 8y and 8y is 0. 7z minus 11z is negative 4z. Negative 26 plus 18 is negative 8. Solving this, I'm going to divide both sides by negative 4. So we get z is equal to 2. Now I have one of my answers, okay? So I need to find, and at this point, I can just plug in. But I need to plug this into either D or E because it only has one other variable. It doesn't matter which one. I am going to choose E for no reason other than because I can. So I'm going to plug in 2 into equation E. So I'm going to take 8y minus 11 times 2 equals 18. So that gives me 8y minus 22 equals 18. I'm going to add 22 to both sides. Gives me 40. Divide both sides by 8. Y equals 5. So I got two answers, okay? I got Z and Y. Well, if I have Z and Y, I can find X by plugging into one of the original ones. I know that this is getting huge, all right? It is getting big, but I'm going to plug that into either A, B, or C, okay? I'm going to choose B because it is smaller, okay? So I'm going to use B. All right, so we know X, or we know Y, and we know Z, so I'm going to plug those in. So I don't know X, so it is 2X minus 3 times Y, but Y we know is 5, plus 5Z, and Z is 2, so I'm going to plug in 2, equals negative 7. Now, I could have used A or C equations, and you would get the right answer. It doesn't matter which one you use, okay? So 2x minus 15 plus 10 equals negative 7. Add like terms. So 2x minus 5 is equal to negative 7. Add 5 to both sides. 2x is equal to negative 2. And then divide both sides by 2. And we get x equals negative 1. There's my third answer. So your final answer, let me zoom out a little bit so you can see everything. Your final answer will be So the x is first, so it's -1, and then y is 5, and then z, which is 2. This should work in any of the 3 equations and make it true. And that's a way you can check it. You can plug it back in and check it. All right, that is as far as we're going to go today. We'll do more examples tomorrow. Bye.